So in this particular question, we're told that a single cylinder vertical petrol engine has a mass of 200 kg and is mounted upon a steel chassis frame. The vertical static deflection of the frame is 2.4 mm due to the weight of the engine. The reciprocating part of the engine has a mass of 9 kg and moves through a vertical stroke of 160 mm with simple harmonic motion. A dashpot with a damping coefficient of 1 Newton per millimeter per second is also used to dampen the vibration. Considering that the steady state of vibration is reached, determine 1. Amplitude of the first vibration if the driving shaft rotates at 500 rpm. 2. The speed of the driving shaft at which resonance will occur. Okay, so the first one we have to expect to find the amplitude of the first vibration. So amplitude of the first vibration is also the same thing as the maximum displacement, and this is the formula. Okay, so now since this is the formula, we need to calculate the value of S, which is the spring stiffness. What is the stiffness? So stiffness is given by weight over deflection, and weight is given by mg. So m from the question is 200, g is acceleration due to gravity, which is 9.81 over deflection. Now the question will be given deflection as 2.4 exponential minus 3. Okay, this is it here. We have it 2.4 millimeters, so we convert it to meter. So we have it as 2.4 exponential minus 3. Okay, so that means the stiffness becomes 8.175 exponential 5 Newton per meter. Okay, so now known our S. Now we need to find our omega. We need to find the frequency, so which is omega in rads per second. So omega in rad per second is given by 2 pi n over 60. From the question we've been given n. We've been given n as 500 rpm. Okay, so that means we have 2 pi 500 over 60, and that is 52.36 rads per second. So omega is our frequency in rad per second. We got it as 52.36 rad per second. Okay, so now from the question we're also given damping coefficient C as 1 Newton per millimeter per second. So in converting into per meter, we have it multiplied by 10 raised to power 3, and that becomes 1000 Newton per meter per second. Okay, so the reciprocating parts of the engine move with a simple harmonic motion. Hence, the centrifugal force due to the reciprocating parts will be having a simple harmonic motion. So this centrifugal force is the applied force. Now, since the length of stroke is L, which is 160 mm, hence the radius of the crank is given by L over 2. So the length of stroke, which is 160 mm, is converted to 0.16 meter. Okay, so that means the radius of crank is 0.08 meter. So this is the relationship between the radius of the crank and a length of stroke. Okay, and a length of stroke. So of course, you know, when we are talking of stroke, we are talking of movement from the top dead center to the bottom dead center by the piston which is connected to the connecting rod. Okay, all right, so that aside, now centrifugal force is given by m omega squared r. Now from the question we've been told that the mass of the reciprocating part is 9. We've been able to calculate the frequency in rad per second as 52.36, so everything squared, and then now the radius we've calculated as 0.08. So it means the force applied is given by 1973.93 Newton. Okay, So now we've known our force, we've known the stiffness, we know 200 as the mass acting on the engine, we've known our omega, the frequency, we also know the damping coefficient, which is 1000, and then we multiplied. So this is going to be multiplied by the frequency all squared. Okay, so by the time you simplify the whole of this, you find the square root. So this divided by this, you are going to have 0.0072 meters. So this is the maximum displacement. Okay, so this is the maximum displacement or the amplitude of the first vibration. So the second question now says we're supposed to find the speed of the driving shaft at which resonance occur. So it means for us to have resonance, it means omega will be equals to omega n. Okay, so now what is our omega n? Omega n is given by square root of s over m, and now we know s, we also know m. So that means, that implies that our omega n is 63.93 rads per second. Now since omega n is not equal to omega, and now from the question we have been given we are expected to find the speed of the driving shaft. So n here is the speed. So now since omega is equal to omega n, and now our omega is 63.93. so that means we are going to make n the surrogate formula, which is the speed. So n becomes omega 60 over 2 pi. So what is omega? Omega is 63.93 multiplied by 60 over 2 pi, and that means our n, which is the speed, is given by 610.5 rpm, revolution per minute. Correct. So this is the final answer.